If you're not interested in even the basic technicalities of building database systems, skip this video and jump to the demonstration videos in parts 4, 5, and 6 of this series. In part 1 of this series, I briefly outlined some basic aspects of CIPO's Trademark XML data, and I showed how you can download the data, which is represented by the XML icon on the left of this slide. In part 2, I explained that in order to do anything interesting, you need to pull the information out of the XML files and put it into some sort of database, as represented by the shred arrow on this slide. One useful type of database is a so-called multi-dimensional data warehouse having a star schema. I'll explain star schema shortly. If you've got such a data warehouse, you can run all sorts of SQL, that's sequential query logic, queries against the data warehouse and format the results for presentation to users, as I'll demonstrate in parts 4 and 6 of this series. You can also use a multi-dimensional data warehouse to build a so-called OLAP cube by running an online analytical processing process as represented by the OLAP arrow on this slide. You can then run MDX, that's multi-dimensional expressions, against the cube to derive business intelligence, as I'll demonstrate in part 5 of this series. So, what's a dimension? Well, in the context of CIPO's Trademark XML data, you could have a trademark dimension, a trademark owner dimension, an agent dimension, etc. Recall that CIPO's latest global dataset, that's the 5 October 2019 dataset, contains over 1.6 million XML files. To construct a trademark dimension, the XML shredder that I mentioned in part 2 of this series would extract the trademark information from each XML file and store it in a trademark dimension, as shown here. I'll explain that key column in a moment. Now, does this mean that we would have over 1.6 million entries in our trademark dimension table? No, and that's the point. As trademark practitioners know, it's common for various reasons to encounter multiple instances of the same trademark. It turns out that only, in quotation marks, about 1.3 million unique entries are required in a trademark dimension table in order to represent every trademark found in CIPO's 5 October 2019 global dataset. Similarly, you can have a trademark owner dimension. In this case, the XML shredder would extract the trademark owner information from each XML file and store it in a separate trademark dimension table, as shown here. Again, I'll explain that key column shortly. It's well known that a single trademark owner may own multiple trademarks, perhaps dozens or even hundreds. It turns out that only, again in quotation marks, about 600,000 unique entries are required in a trademark owner dimension table to represent every trademark owner found in CIPO's 5 October 2019 global dataset. In similar fashion, your XML shredder would extract agent information from each XML file and store it in an agent dimension table, and so on to build whatever dimension tables you require. To tie things together, we use something called a fact table, as shown here. Notice that this fact table has a trademark key column and a trademark owner key column. Each entry in the trademark key column points to a correspondingly keyed entry in the trademark dimension table. So the first row in this fact table has trademark key value 1258505. You can think of that as a pointer to the trademark dimension table entry having the same key value, namely 1258505. In this way, we avoid storing the trademark itself in the fact table. We only need to store unique things, these are called facts, such as the actual trademark application serial numbers, and you can see there's a column for those in this fact table. This saves space and makes for faster lookups. Space and speed matter when you're dealing with millions of trademark records. Similarly, each entry in the trademark owner key column points to a correspondingly keyed entry in the trademark owner dimension table. So, for example, the 8th row in this fact table has a trademark owner key value 3336. Now we've avoided storing the trademark owner's name in the fact table, which again saves space and improves speed. Suppose that the trademark owner corresponding to that key value 3336 owns 15 different trademarks. In that case, there would be 15 rows in the fact table, one row for each of those 15 trademarks. In each of those 15 rows, the same value, 3336, would appear in the trademark owner key column, such that every one of those rows would point to one and only one entry in the trademark owner dimension table having the same 3336 key value. Here we see the fact table with pointers, that is, keys, pointing to the trademark and trademark owner dimension tables, respectively. More dimension tables can be added in the same way, with additional key pointer columns added to the fact table for each dimension. The tagged fields in CIPO's Trademark XML data can be used to create many other useful dimensions. For example, each XML file is tagged to indicate the language, English or French, in which the application was filed. As you'll see in the upcoming Part 5 demo, a language dimension lets you slice and dice the data based on language. Similarly, with a mark type dimension, you can quickly rearrange data sets to focus on word marks, design marks, motion marks, etc. If you've got a mark status dimension, you can further rearrange your data to focus on only those marks whose current status is of interest to you. Maybe you want to look only at marks which are approved, allowed, or registered. If you've also got an agent dimension, you can further narrow the focus to only those marks for which your firm is the agent of record. With a suitably configured date dimension, you can restrict the focus even further to a selected date range, and so on. When you put it together, you ideally wind up with something called a star schema, as shown here. The idea is that you have your fact table in the center, with multiple dimension tables arranged around the fact table in a star-like pattern. Star schemas are common in data warehouse design, but may strike you as odd if you're familiar with typical transactional database designs. A major advantage of a star schema is speed. It's not uncommon to encounter fact tables with millions or even hundreds of millions, sometimes billions of data rows. A typical transactional database in, say, third normal form would probably not facilitate the same query lookup speed if you're dealing with millions of rows. Recall I said that you ideally wind up with a star schema. Unfortunately, real-world systems can rarely be accommodated by a pure star schema design. You often wind up snowflaking your schema, as they say, as shown here. Notice the addition of a new geography dimension table. That table contains address information. For example, agents can have addresses, and so can trademark owners. You don't want to maintain two separate geography dimension tables, one for agents and another for trademark owners. You just want one geography dimension table to keep things simple. So you build a single geography dimension table and you link it to each of your agent and trademark owner dimension tables, again using key pointers as I explained previously. That linking of dimension tables to other dimension tables is called snowflaking, and it results in some interesting challenges for data warehouse builders. Of course, there's more to designing and building a multi-dimensional data warehouse than I can convey here. But the basic dimensional concepts that I've outlined may help you understand other parts of this series, particularly the OLAP cube that I'll demonstrate in Part 5. In Part 4 of this series, I'll demonstrate an interface enabling user interaction with the data warehouse. Feel free to email me if you have questions or comments.